Okay, so today we're going to talk about equations in two variables. Does anybody remember equation with two variables from last year, from intro? Yeah, give me an example.
Like 3x equals 5y.
Sure, you could have that. That's an equation with two.
3x plus 5y equals something.
Exactly.
7.
Yeah. So I'm going to compare these two. First of all, I'm going to show you an equation with one variable, which we're really used to doing this. How do we solve for x for 2x minus 3 equals 7? Yeah.
Oh, add 3 to both sides?
Yeah, add 3 and
Divide by 2.
divide by 2 and you get
5.
5. So your solution is a number, right? In other words, if I plug in 5 to the left in place of x, this equation is going to be true. The left side will be equal to the right side. Well, with two variable equation, it's a little bit different. So for example, let me give you a simple one. X plus y equals to 3, something like this. Harrison, what can you tell me about the solution for this equation?
Example 1.
Yeah.
X plus y equals
Right, and can you tell me the solution that makes this true?
3. No.
No. Okay, what about x and y? What kind of value can you plug in for x and y so that it equals to 3 when you add them?
0.
0?
1, 2, 1.
1? Okay, if x is 0, then y has to be
3.
3. Because 0 plus 3 is
3.
3. Right? Harrison, are there any other numbers you could plug in other than 0 for x? What about x equals 1? What if x equals 1? Y has to be 2. Okay, and yeah, I mean, sure, you could write 3 equals to, say it again? Y minus x. Really? 3 is equal. 3 minus y, sure, you could solve for x that way. Are there any other solutions you could think of? Yes.
Oh, x is equal to what? 3 minus y?
X equals to 3 minus y? Okay. But that's not a solution. That's just transforming these equations. Can somebody give me the solution? We found one. When x equals 0, y has to be 3, so how do you write that solution? 0 comma 3. Right, you guys remember this?
Yeah.
So the solution for two variable equation, you don't just get a number, you get an what? Anybody? Order pairs, that's correct. You guys remember this from last year?
Oh, yeah.
Remember, for the solution for this is an order pair. 0 comma 3. 0 meaning x has to be 0. 3 is the y, order pair. Can somebody give me another order pair that works for this one? Yes. 1 comma 2. 1, that's the x coordinate. Y. 2 is the y coordinate. Are there any other? Yes. Negative 6 and negative 6 comma 9. Negative 6 comma 9. Doesn't that give you 3? If x is negative 6 and y is 9, don't you get 3? Okay. How many solutions are there like this? The order pair. There are infinitely many. Is it possible to write all of them? No, it's not possible because there's so many of them. So on your homework, they're gonna ask you to write 3 solutions or something like that. Okay. So let me show you how to do that. Are you ready? So let's see if you remember. So if they ask you, so because they cannot say list all of them because it'll take you forever. Right. There are infinitely many of them. They're gonna ask you, give me 3, right? Solutions for this. Oh, there's so many. We could give you 3. Some of these you could just think it in your head, right? We just we did now, right? We know that they're, but if it's not this simple, right? You wanna follow this method here. First, you solve for y. Okay? So even though this is a very simple one, you could actually figure out in your head. Not everyone will be like this. So if they ask you to find 3 solutions or something like that, you solve for y. Anais, did you have a question?
Can you solve for x?
You could solve for x, but because you see y, we solve for y in a minute. Okay, let's see if you can figure this out. So I'm going to solve for y. So of course, to solve for y, some of you said it already. What do? Subtract? Yeah.
Solve for y, 3 minus x.
Right. So you subtract x from both sides, and you get 3 minus x. I'm not going to write 3 minus x. I'm going to write actually y equals to negative x plus 3. Does anybody know why I write the variable first, that x? You could write 3 minus x, but I like to write y equals to negative x plus 3. Yeah. Huh? I like addition. Well, no, I subtracted y from both sides. What I'm saying is Chirac says, why not write 3? Oh, because I like addition, I see. But you want to write the x first. Does anybody remember this form from last year? Yes. Yeah, this is in slope-intercept form. So later, you're going to have to write things in slope-intercept form anyway. Why not start writing it that way? Does that make sense? Anyway, so that's step 1. And Anais, as I do this, think about why I solve for y, not x, okay? Okay, does that make sense? Think about why. Not only that, yeah, one of the reasons is because it's in slope-intercept form. And secondly, it's actually easier this way because you'll see why in a minute. Then second step is plug it in, right? Here, write this down. Plug in x with nice number. So when I say nice, I mean easiest one that you could plug it in. So do you think 0 is the easiest? You're right. So as a matter of fact, why don't you make this chart? So you're going to have x, you're going to have y, and of course you're going to have the solution, x comma y, the order pair. So make a chart like this. Go ahead. So what is the easiest or nicest number I could plug in for x? 0. Isn't that the easiest? Do you want to plug in like 3,700? No, you don't want to. Yeah. Okay, so plug in 0. Aaron, when I plug in 0, what do I get?
For x?
Yeah, I'm going to plug in x equals to 0. Then it'll give me y, wouldn't it? Because we solve for y, you see? So what do we get as y value? 3. When you plug in, you should always use what? You guys remember? Parentheses.
Oh, I remember this.
Use parentheses. Cause, and there you go. I got the order pair 0, 3. Anais, you see why I solve for y?
Oh, yeah.
Yeah, why?
Yeah,
Why do I do that?
Well, because you get y equals 3.
Yeah, you get y equals 3 easily that way. You plug in x. Don't you plug in x? Don't you, like, you know, it's in alphabetical order. Let's plug in x equals something. Then when you solve for y, you can get y right away.
But wouldn't it be the same if you had x equals negative y plus 3?
Yeah, but then you have to write in different order. X comes first, doesn't it?
Yeah.
So then you would get 3, 0. Then you might write 3, 0, which would be wrong. You want to write an order pair. X, then y, not y, then x. You know what I mean?
Okay.
So it's just best if you plug in x and then get y, right? Yeah, you could do it the other way around, but isn't it easier to just do it in that order? X, then y. Right, guys? Because if you write 3, 0, is that same as 0, 3?
Yes. No.
No, of course not. By the way, why is this called order pair? Where do they get this order from? Yeah.
Because the x-axis is the y-axis.
Yes, exactly right. It's in what kind of order is this in?
Slope-intercept.
No, look at the order. What sort of order is this 0, 3 in? Yes.
Oh, this is like the xy axis.
This was Trogdon.
No.
This is the alphabet.
Yes, it's in alphabetical order. X comes before y, so that's why it's called order. Why do they call it pair?
Because they're pairs. There's two.
Yeah, there are 2 numbers. By the way, on your homework tonight, they don't use x and y. Could I use a, b? Yeah. Do you think you're gonna write that in order pair also?
Yes.
That's
Why
correct.
do they call a pair a pair?
What do you mean? So there's our first order pair, 0, 3. Now, what's the easiest number other than 0? Can I plug in?
One.
Yeah, 1. I will plug in. Everybody go ahead and plug in 1, see what you get. Okay. And let's say they ask for 3 of them. What are you going to plug in after 1? 2. Okay, everybody go ahead and try.
Done.
Okay, so did you all use parentheses? Did you get 1, 2 for 1?
Yeah.
What about 2? What'd you get? 2, 1? You all get 2, 1? Okay. And of course, I could keep going, right? But for something like this, they can't ask you to list everything because it'll take you forever, right? You could keep on plugging in. I mean, you could plug in some negative numbers, right? Some fractions if you like. But anyway, so there you are. Any question? This easy?
Yeah.
So on your homework tonight, it's gonna ask you to like give me 3 solutions or 5 solutions, right? Depending on what they ask. Here's another type of question they could ask. They could ask you something like this. Instead of asking you like give me 3 possible solutions or something, 3 solutions or 5, They could say, is 5, -1, the order pair, a solution to the equation x minus y equals to 4? So that's another type they could ask. Okay, write it down. Is 5, -1 a solution of the equation x minus y equals to 4? What would you do in this? Yeah. Owen?
Equal sign is, right? Like the word is.
Oh, no, this is just asking. Is 5, -1. You're not translating into an equation. You have an equation. It's x minus y equals to 4. They're asking Owen, 5, -1. Is that a solution to this? How do we figure this out? Elizabeth? Yeah, I just plug it in. What do I plug in for 5? In place of? Yes? X. What about -1? Yeah. Go ahead, everybody's plug it in. And of course, use what? Parentheses when you plug it in, okay? Because you don't want to make silly mistakes. Go ahead. Is this order pair a solution?
No.
No? Yeah, it's not. Why not? Yeah.
Because the y, if you put in -1 and y, it'd be positive because it's already negative.
Right. You get 6. Don't you? 6 doesn't equal to 4. So what should I write? Yeah. That's right. Some of you said no solution. That would be wrong. You have to write it this way. You have to write 5, -1 is not a solution, like Kristen said. If you say no solution, then you'll be wrong. Why? Why would that be wrong? Sierra. Yeah, the equation does have solution. It's just what? Yeah, now 5, -1 happens to be not a solution, right? How many solutions are there for this one? Yeah, x minus y equals 4. There are many. I could even think of one. X could be 1, y could be -3, right? Or something. Right? There are many, infinitely many of them. It's just that 5, -1, right, happens to be not one of them. Does that make sense? Yeah.
On the homework, are we gonna have to like they're gonna ask that question and we're gonna have to tell them what is the solution?
No, if they just say, is 5, 1 a solution, you just say yes or no.
Oh, okay.
You say yes, it is a solution. No, it is not a solution. If you write no solution, that'd be wrong. Right? Because, yeah, you have to say it is not a solution. This particular point, the order pair, right, is not a solution to this equation. But there are other solutions there. By the way, didn't we say then x minus y equals 4, there are infinitely many solutions? Doesn't that mean every order pair is a solution? No. Okay. Not every order pair is a solution. There are particular ones that is a solution for this, and there happens to be infinitely many of them, right? But 5, -1 is not one of them. Does that make sense? Okay. May I move on? All right. Another type of question they're going to ask you is this. They say, I put a star on this one because sometimes people have trouble doing this, but it's not that hard. Solve 3x plus 4y equals 12 if x and y are whole numbers.
Any whole numbers?
Right, any whole numbers. So first of all, aren't there infinitely many solutions?
Of course.
Okay. So what do they mean by whole numbers? If they're kind of telling you that they don't want every solution. Yeah. What are whole numbers, Anais?
1, 2, 3.
Uh-oh. Okay, whole number is WHOLD. You guys remember that?
Oh, yeah.
Okay, okay, hold on. Judy, what do you think? Yeah. These are numbers like 0, 1. What do we call numbers that start with 1? Those are the 1, 2, 3. Those are the? You say again? Oh, natural number. You're right. Okay. Anyway, so whole numbers we start with 0. Okay, remember? They're sort of restricting the answers that you could get, right? In other words, can your order pair have negatives in them?
No.
Can your order pairs have decimals in them?
No.
Can your order pairs have fractions in them? No. They want solutions that are whole numbers only. Okay. So, even though there may be infinitely many solutions, they're restricting your solution. Does that make sense? So you may get, right? Obviously, you're not going to get really a lot of them, right? Because obviously they can ask you like, right? If there's like whole number solutions that are like 100, they're not going to ask you to list them all, right? But so this is going to restrict your solution, and so let's see how that works out. And actually, the same way that we did with example 1. What's our step 1 in order to find the solutions for this? Yeah. Solve for y. So how do we solve for y for this one, Emily? Yeah, subtract 3x, then what? Divide both sides by, or when you, okay, you get 4y equals to negative 3x plus 12, divide both sides by 4. When we do this, Audrey, what does that come out to be? Y equals, yeah, negative 3, 4x plus 3. Is that what we get? Again, remember this is called the slope-intercept form, which we'll learn soon. Okay. I think a lot of you already know. So that's step 1. Step 2 is what? Plug in nice values for x. Because when you plug in x, that's why we solve for y. When you plug in x, you get y, right? So you think you should do that chart? Yes. Go ahead, everybody, draw the chart. Judy, what was your question again?
How many solutions?
Right. How many solutions do we need to write down, right? Well, this time they didn't. Well, no, they didn't ask you to write 3 this time. They didn't say anything. All they said was they want the answers to be whole number. So Judy, you're right. Well, aren't there infinitely many solutions? Let's see how this one sort of. You think there's going to be one solution? Not quite. So let's figure it out. Let's see how we could do this. So Judy, keep that in mind. You're right. There's so many solutions. How many are we going to write? But as we actually plug in numbers, it will kind of be clear to us how many or what we could write. So first of all, we're going to plug in x equals to, by the way, can I plug in x equals to negative 1?
No,
No. Why not, class?
it's not a whole number.
Yeah, it's not a whole number. What does the whole number start with? 0. So guess what we're going to plug in? 0. Everybody go ahead and plug in 0. It's easy. Go ahead, everybody. Plug in 0. Of course, use parentheses. I get y equals to, class? What? 3. Is that a solution that I could use? 0, comma 3? Why? Why is it the solution that we could use here? How about Malia? They're whole numbers. 0 and 3. Aren't they all both whole numbers? Yeah. So that's fine. What am I going to then plug in next? Let's do this step by step, right? Next whole number other than 0 is, yeah, Chansu? 1. So let's plug in 1. Everybody go ahead and plug in 1. See what you get. I'll wait. Okay. Did you all plug in 1? Yeah. Matthew, what'd you get?
I got y equals
2 and? 2 and a 4. Oh, okay. So, 9 over 4, right?
Well, that's huge. Yeah.
Okay. That's what?
Yeah.
Well, I wrote no. How come I wrote no? Yeah, tell me. Why do you think I wrote no for my? Why didn't I write 1 comma 9 over 4?
Not a whole number.
Wait. Hey, Kobe, wait. What? Yeah, because, well, 1 is a whole number, but they want both of them, right? X and Y coordinates to be whole numbers. So you can't use that one. So let's do it step by step again. Guess what I'm going to plug in next? 2. Go ahead. Plug in 2. See what you get. All right. Who has the answer for plugging in 2? What do you get there? Let's see. How about, go ahead, John? 3 over 2. How many people got 3 over 2? Raise your hand. Okay. All right, Emily, did you write no on that one too? Yeah, why not? Why is it that we can't use this as our solution? Again, Aaron?
It's not a whole number.
Yeah, you get, the answer is not a whole number. What about when I plug in 3? Go ahead, everybody try to plug in 3. What do you get? Cameron, what'd you get? Yeah, for 3. Oh, do we need more time? 3/4? Again, it is a fraction, right? Yeah, it doesn't work. I didn't even actually add them. Okay, I can see it's going to be a fraction, right? If you add a fraction times a whole number, it's going to be a fraction, right? So, but 4, does that work? Yes. Yeah, this one works. Why? Why does the 4? Okay, why does the 4? Yeah. They cancel each other out. So as you can see, it gets 0. Do you guys see the pattern here? Yep. Look at the denominator. My denominator is 4, right? And if that's 4, do you think, so when you're doing your homework, as you do many of these, you will figure out, oh, you know what? For this one, you don't even have to try 1, 2, 3. You know what I mean? Because you know it's going to come out to be a fraction, right? So you would actually try the multiples of 4s, right? Because your denominator is 4. Does that make sense? Anyway, so that one works. What about then next thing? Let's just plug in 5. Go ahead, everybody try plug in 5, see what you get. I imagine we're going to get a what? Fraction, but actually this one, you could actually try 5, or you could try 8 if you want to. It's up to you, but try it. You will see the next one will tell you very important thing about this problem. Okay, go ahead. Maybe. All right, so did you all plug in 5, or you could plug in 8, right? Because you see the pattern that if you're plugging 5, you're going to get a fraction, but 5 or 8, doesn't matter. I wrote down stop right here. Even if you put down 8, why do we not need to try more whole numbers? Because don't you have to try 6, 7, 8, 9, 10, 11, 12, and so forth? Right? If not 6, 7, don't you want to try multiples of 4? So it's like 4, 8, 12, and so forth. Why not? Why do I stop at this point? Andrew?
Because negative.
Yeah, no matter what you plug in, as you increase the number of x, right? It's going to come out to be negative every time. In other words, it's going to get bigger than 3, right? Because you got a negative. Right, guys? Look, you have a negative times some positive number, right? And that's that positive number that x increases, right? It's going to get bigger and bigger. That negative is going to get bigger and bigger, and it's always going to be negative. So can you have a negative as your whole number solution? No. So you see how, so Judy, does this answer your question? Like, they don't have to tell you how many solutions they're looking for. You have to figure that out yourself, right? There will be a time where, right, the y is going to become negative, right? And it's going to get more negative, right, as you increase the x. So therefore, this is when you stop. So how do we write the solution? We found, how many solutions have we found that are, that are whole numbers? Kyle, can you tell me what those are?
0 and 0, 0 and 3, and 4 and 0.
That's correct. The order pairs are, every time you talk about the solution for these, they're order pairs, right? So 0, 3, and 4, 0 are the only order pairs that are whole numbers. Are there any others? No. So do they have to tell you how many they want? You see, that's kind of nice, right? So that's how they ask you on your homework, okay? They ask you, give me the whole number solution. Does that make sense? Do you understand? Okay. Do you think you could do something like this on your own?
Yes.
Go ahead. Yes, you can. Okay. Go ahead. Try these. Try number 4. And since you're sitting as a group, Colby, you could ask your group members, help each other out, okay? It's not a test. So if you're not so sure, ask your group. So they want, again, whole number solutions, okay? Go ahead. So Nelly, what did you plug in first for this one? Well, we have to solve for y, right? What did you do? Good. Y equals to negative 2x plus 8, and of course you have this chart. Nelly, what did you plug in first? 0. What did you get for 0? 8. Did you all get 0, 8?
Oh yeah.
Okay, good. What should I plug in next, Matthew? 1, because, you know, we do it step by step. After 0 is 1, the whole number, right? So what do I get when I plug in 1? Okay, guys, listen. Andrew, Cameron. Okay, what did you say? 1, 6. Did you all get 1, 6? Yes. Good. Could I use that? Yes. Is that okay? Good. Owen, what do I get next? What did you plug in? 2 and 4. Okay. Could I use 2, 4? Talene, what do I plug in next? 3 and 2. What about next? What should I plug in here? Yes, Frana? 4 and 0. Good. Then I plug in 5, and you know you get some. Yeah, this is how I know when to stop. Because listen, you start getting negative, and as you can see, as I increase the value of x, right, guys? Hello. Yeah, it's going to get bigger. You're gonna get bigger negative numbers, right? So yeah, question.
Can you stop when you see 0 because you know it's gonna get below 0 there?
Right, that's true. So if you can kind of stop. Well, sometimes you may not see 0. It may go 1 to like negative something. So that's not really a good way to. Does that make sense? Yeah. So you don't just because there's 0. Okay. So now, do you see that if they give you questions like this, the value, look at the value of y. What's happening as the value of x increases? The value of y is decreasing by, in this case, decreasing by 2. It has to decrease. Can they give you one where the y value also increase? No. Then it's going to go forever, right? You have to write down, there will be infinitely many solutions, right? That are whole numbers. Does that make sense? Hello guys, do you understand? So if they ever give you something like this, the value of y would always decrease. Okay. Anyway, any question on this? Are we good?
Yes, sir.
Okay, good. So how would you write the answers for this then? Right, so raise your hand. How do I write the answers for this? Ali, what would your answer be? Uh-huh. Good. That's right. There are 5 of these order pairs, right? So this is how you write down the solutions that are whole number. Does that make sense? Yes? Okay, we're gonna change the gear a little bit and give you some vocabulary words that you should know for chapter 8. Okay. I think these are something that you've already seen before. So, all right. Okay, so I think a lot of you already know, like, what do we call this whole thing where you have the coordinate plane right here, coordinate plane. The axis, yeah, right. The axis that goes to left, right here. What do we call this axis? The one that goes up top, the vertically is the y-axis. You all know the origin, right? That's where 0, 0. So say what? Oh, okay. Oh, okay. It looks like it now. Okay, so then the order pair is 2, 3. Why do they call it 2, 3? Why can't it be 3, 2? Because don't you have to go up 3 and to the right 2? Don't you get to A?
Eyes overrun.
That's slope. So, yeah, it's in alphabetical order, right? So you have to give me the x, then y. Remember, x goes to left, right, and then y gives you up and down, right? So in order to get to A, by the way, do you see why it's called origin? Because you always start at the origin and you go to the right 2 and up 3. Does that make sense? Okay. So that's why this is called the origin, right? In order to get the order pair for B, you have to start the origin, go to the left or right or up down first. Left, right, because that's the x comma y. X is the So left 2, that's why it's negative 2. Down 3, so that's why it's negative 3. You guys all remember this?
Yeah.
All right. Good. Okay, so write it down. It's nice. Okay, so the order pair 2, 3. What do we call this 2 only? Raise your hand if you know what it's called. Yes, sir.
Is the X?
X what? Yes.
Coordinate.
X coordinate. What about 3? Andrew?
Y coordinate?
That's the y coordinate. The book gives you another name for the x and the y coordinate. Does anybody know what x coordinate is called? It starts with A. Yeah. This we don't really use this much. Here, let me give it to you. It's called the abscissa, and y is the ordinate. Okay. Right, you know what? Okay, so listen. This is important. Sometimes they use these words. Okay, the book gives it to you also. So just remember, x, y is in alphabetical order. So are these A, right, and O. Which one comes before, A or O? In alphabetical A. So remember x with A and y with the O. Is that okay? All right. So just know that you don't have to memorize or anything. Just kind of know that A, is in that order. You may see that sometimes. Okay. So again, this is a coordinate plane. In a coordinate plane, you have x-axis and y-axis. Do you see how coordinate plane can be divided into 4 regions with the x and y-axis? Do you guys remember what this one is called? This region? Yeah.
First one.
Yeah, first quadrant. Okay. This is. I'm just gonna write Q for quadrant. There are 4 quadrants, right? Which one is the second quadrant then? Okay, raise your hand. Raise your hand. Yes, Matthew. This one. This one down here. Down. Oh, okay. So this is actually Q2. This is Q. Yeah, they use Roman. Do you have to use Roman numeral? No. Okay, you could. This is Q4. By the way, some of you already know this. Okay, what is this whole thing called? Coordinate plane. Coordinate plane start with what letter? So if you go from, so here's a way that you will never forget. Go from 1 to 4. you could write C like that. Okay, does that make sense?
C for coordinates.
So yeah, C for coordinates. So I have the same one right here. So remember, C for coordinate plane. Okay. So if it divides into 4 quadrants. If you remember the C, you will now forget which one's which. Does that make sense? How many people have seen this before? Good. Now you all have. So some of you ask, okay, the origin. Which quadrant is 0, 0, the origin in? Actually, X and Y axis?
None of them.
Yeah, none of them. It's not in any other quadrant. Okay, it's on the X and Y axis if you say that. Does that make sense? So if on the test, like they give you like, I don't know, 0.40. Which quadrant is 40 in? You say, well, it's not in any other quadrant. It's on the positive X axis. Does that make sense? So that's a good, yeah, that'll be a trick question if they say that. That's good, okay. So if the point is on the X axis or Y axis or something like this, they're not in any other quadrant, okay? They're on the X or Y axis, okay? Does that make sense? Very good question. Very good question. If you have an equation that looks something like this, 2x plus y equals to 6, Anais?
Yeah.
These equation that has this form, something times x plus, what is multiplying y right here? 1. 1 times y equals some 6. Any equation that has this form are called linear equation. So write this down. Yeah, do you see line in linear equation? Why do you suppose these equations are called linear equation? If you have to graph them, yeah, you get a line, you're right. So write this down. All linear equations can be written in this form. Ax, in here, what's my A in this 2? What's my B in this example? 1. It's 1 times y, you see? Does that make sense? What's your C in this example? 6. Do you see that? So any equation where A, B, C are real numbers and A and B are not both 0, you have a linear equation. So if anytime you see an equation that has this form, ax plus by equals to c, where a, b, c are some real numbers, why do I write a and b not both 0? Why do you think that's necessary? Well, you're writing down. Let me give you some time to write. Sorry. Go ahead and write it down. Let me ask that question again in a minute. So the question that I was asking was, why do I have to have this a and b not both 0 part in this definition? It's actually a definition if you want to think about it. Anybody see why we need that there? Does that mean a could be 0? Yes.
Oh, yeah.
It's okay for a to be. Does it mean b could be 0? But what if when both of them are both 0? Yeah, why not? It won't be a line, you're right. It's not going to be an equation either. You don't have any variables there, right? You get 0 equals to some number. You know what I mean? That's not an equation really. Yes?
What if it's one of them is negative?
That's fine. You could have negative. Like here, I can make this one negative if you want. Here. You want me to make that one negative? It's still a linear equation.
So what's the difference between a linear and a non-linear? What does it come like?
Linear and what?
Non-linear.
Oh, actually, nonlinear equation would have x to the 2nd power or something like this. Y to the 3rd power. Or you could have x times y. That's not linear equation. Does that make sense? Yeah, A, B, C, it could be any real numbers, right? Real numbers means any numbers on the number line, right? So it could be negative, positive, decimals. Like here, you have irrational number like rad 5. Does this make sense, guys? So anytime you have this form where you have ax plus by equals to c, every time you graph this equation, you get a line. That's why it's called linear equation. You see line, linear, okay? Within this linear equation, there are special ones. If a, b, c happens to be integers, you guys remember what integers are? You don't remember? What? It's like whole numbers, but with all the negatives. So 0, 1, 2, 3, 4, but then you include -1, -2, -3, right? So if a, b, c happens to be integers, this has a special name. It's called something form. Anybody know what that's called? It's called, no, not slope-intercept. It's called standard form is correct. So if it happens to be, so integers, some of you forgot what integers are. So integers are like, let me write it up here. 0, 1, 2, 3, ... And also you could have -1, what? -2, ... Oops. So if ABCs are some integers where you don't have any fractions or decimals, like here, 5. Let me just put negative 5 just in case. Negative 5x plus 7y equals to negative 5, right? Aren't they all integers? ABC? What's your A in this one? What's your 5? What's your B? These are the coefficients, right? What's your C? Negative 5. Then we call that A. It's a linear equation, but also it's a standard form. Does that make sense? So remember that any form that has this form, if ABC are any real numbers, then you have their linear equation. But within this linear equation, if ABC are integers, then it's called a standard form. Okay. Any question?